Welcome back, everyone. Welcome back after the break. Let me introduce myself to start. My name is Hugh McNamara. I'm the data science lead at IntelliSense.io.
And I'm Chris Olsen. I'm the lead engineer at IntelliSense.io.
So we're going to be talking about deploying AI and big data at scale in mining. As with all of the other talks, there will be some time for questions at the end, and we'll be handling questions that you can submit on Slido, either through the widget on the page or directly at slido.com. So please add questions, vote on the ones you want to hear answered, and we'll get to them at the end. So you'll have heard today a lot of talk about some of the outcomes and the outputs of models. It seems like you can't escape the term AI or deep learning or machine learning in the news these days. And it can be hard for anyone really to separate things that are valuable from the things that are hype, and to understand what the hype is. At IntelliSense.io, we've learned a few things over the years that we've been working on this. We've learned some things that are specific to the mining space, and rather than telling a mining industry what to do in a space where it seems like you've slapped the word neural net or machine learning on it and it's suddenly a big deal, instead of telling them what we do, we're just going to share a little bit of what we've learned. And really the two things that have made all of these advancements and the rapid progress possible in the last number of years have been the availability of very large data sets, specifically digital data sets, and the availability of lots and lots of computing power.
Yeah, and obviously the forefront of these sort of large data sets are the big tech companies that we hear about, so like Google, Facebook, and others, and they've collected very large data sets of photos, messages, websites, and text, and then struggled to find out what to do with this data, how to organize it. So they've invested heavily in sort of the AI technologies to help them deal with their large data sets. They also happen to have very large computing resources at their fingertips. So Google is estimated to have 2.5 million servers running in 2016. It's probably grown substantially since that point in time. And so they're driving a lot of the frameworks, they're investing and in the frameworks that are then used by other people for a lot of the machine learning and AI in the industries. And so because they're building it, it works with a lot of their infrastructure, right? So Google and Amazon also provide cloud infrastructure, and often the workflows where a lot of the AI fit into that infrastructure. So they've made use of the fact that that infrastructure is available to be able to sort of scale up the resources required in terms of computing to be able to then train and use the neural networks and other machine learning techniques.
That's one of the things about the type of compute resources that are available in the quote cloud are that it's quite elastic. So you can scale it up when you need it, and you can scale it back down when you don't. And this happens to suit machine learning and AI particularly well, because a lot of the high demand, the high performance, and the high computational load takes place when you're investigating the data, when you're learning figuring out what to do with it, and when you're training the model in particular. So in some ways, it is like putting a bunch of data into a pile of linear algebra or a pile of computers and stirring it to see what comes out. But the benefit of doing this type of work on the cloud is that your data scientists don't have to spend a week waiting to know whether they're doing the right thing, and they can spend much shorter times. And so that means that you're highly paid, but probably not highly paid enough. Data scientists aren't wasting time, that they're actually able to work on a shorter loop, a shorter iteration cycle, and develop things much more rapidly by using this highly elastic computing ability. So if you're starting off a journey with machine learning or AI, these are the few things that you'd want to think about. And these are the
Yes.
conditions that have set the stage for this process.
Yeah, so like big data sets, high compute power. You'll need to do retraining quite often, especially in mining with changing conditions, and sort of the potential technologies around and frameworks in AI being driven by sort of these big tech companies. So you have to keep that in mind when you're thinking about where you're going with your compute power needs and how you're going to sort of manage that infrastructure. Yes, and I think that it's important to pull out, like, the compute power is often in the form of GPUs, so graphics cards now being repurposed for this sort of the computational power they have, and then being used in AI and machine learning training.
So the next kind of broad topic, and it's been mentioned before during the sessions today, are around the implications of the cloud and working in the cloud and working with these elastic computing resources, what they entail for computer data security in particular.
Yeah, I think data security is an important topic to bring up. So for the use of cloud in particular, it's been a bit of a slow adoption, we feel, in the mining industry. Other industries have sort of got into the sort of the public cloud a lot quicker, and often people who haven't yet moved into the cloud have perceptions around data security and sort of the ownership of the information, and that sort of can hold that move back, that transition.
And it's striking, actually, that one of the areas where the mining industry has done a lot of work in the last number of years has been around securing the critical infrastructure that runs the mine site. And one of the things that this actually leads to is an opportunity. This is one of the mining industry's strengths. They have expertise in developing strong, secure systems. And even though the cloud on paper or immediately seems like it's breaking some of the principles of those, in actual fact, a lot of the same tools, the same approaches apply just as easily and just as well to securing a cloud setup or cloud deployment as it would in an on-premises or traditional infrastructure.
Mm-hmm. Mm-hmm. Yeah, and so there's a mix of different infrastructures you can make use of. So you obviously have your traditional infrastructure that you're already deploying on site, and then you could choose a sort of a private cloud, what's called a private cloud, or a data center where you've fully managing the equipment you've got, or even sort of the public cloud infrastructure where someone else, such as Amazon or Google, is managing the infrastructure for you, and you can just turn it on and turn it off quite quickly. And so what we've seen is generally that clients are working with all of these, and they have different places where they're happy at the moment. So we've had to support all of these different environments and be able to deploy into all of these separate environments ourselves to fit in with that sort of decisions they've made around their infrastructure and potentially the journey they're having towards a cloud strategy. And obviously that we've sort of we've alluded to some drawbacks of using your on-premise only because of things like GPUs aren't common technology that are in on-premises deployments and could be difficult to source based on like the current practices around supply chains and how you're actually going to get that hardware. But obviously there's some pretty specific reasons that maybe also that lead into this, and one of those is connectivity. So connectivity of mine sites can be a bit of a problem in some cases, and so you want to do some operations potentially on the mine site, and then but still you still probably need to make use of other infrastructure like the cloud infrastructure for things like training. So we do a hybrid deployment model where we can make use of that large infrastructure in the cloud for training and analysis, but also avoid connectivity problems on site by deploying a local system for being able to give results back into systems there. And Mark talked about this a little bit in the release presentation and around the Brains App Lite product that we've built for this. There's some related, so we call this hybrid deployment, but there's some other related terms that you should probably know about, like edge computing and fog computing. They're all basically mean the same thing.
So the combined, we have been able to work with any of the three possibilities: the public cloud, private cloud, or traditional infrastructure. Our standard deployment is the hybrid cloud because we feel this makes best use of the strengths of both the elastic compute resources in the cloud, the availability of things like GPUs, as well as the close connectivity and reliability and robustness of traditional infrastructure on site in the mine. And by combining these, by doing our training in the cloud, deploying and running and inputting the relaying the results of the computations back to the site on traditional infrastructure, we make the best use of both worlds. And the point that Chris mentioned about the reliability of the connection is really important, because already we're going to be having to go on a journey with data quality. And if you add unreliable connections to that, it's only going to make it harder. So the next point we're going to talk, the next topic we're going to look at a little, is about the issue of quality data. Going to give some kind of nice examples, but really we're going to talk about it. Data quality is a journey, and I think it was alluded to in Craig and Grant's presentation earlier today around the stockpile application. Our clients and our customers will have built up processes for using data that have fit the uses and the needs that they were putting that data to. Those uses and needs now have been augmented and added to by the new possibilities, the new value that can be gained through more sophisticated modeling, integrating different data sources together. And that means that it casts a new light on what data is already there. And it means that we need to go on a little bit of a process, a cycle of looking at the data in the new light of new applications, cleaning it, figuring out what's wrong, what the issues are, and improving our policies, or working with our customers to improve the standards and policies, and perhaps to identify areas where we can suggest new measurements or new things that could be added to their data to make it more robust. But I'm going to give a couple of examples. I'm going to start with one from the stockpile. So the stockpile application, we found that in the past, all that was needed was which stockpile was the material being added to. But as soon as you want to start looking at the fancy 3D graphs that Renee and Susan were looking at earlier, you need to know where in the stockpile that material has been dumped. And we found, when we initially looked at some fleet management system data, where the location of truck dumps as recorded in client systems, we would find a scattering of points, some of which would be in reasonable locations, the majority of which, to be fair, but a large number of which would also be outside of the boundaries of the stockpile, perhaps, or even on the road to or from the stockpile. So there's a number of sources of uncertainty or sources of error that is happening here. Some of them would be just uncertainty in the GPS, as it's not an exact measurement of position, but some of them may be things like a manual logging of a dump event that a driver just logged it 10 minutes after he actually did the dump, when he's on the road back to his next stop. And that's a process issue, and we can identify processes there that can help to improve the overall quality of the data.
Yeah. The other issues we've run into is around sort of older data warehousing techniques. So if you're running a historian on site, which most people are, you may not have unlimited sort of hard drive space like you would maybe potentially in an Elastic Cloud solution. So you need to do something to compress the data so you can keep a large amount of it. What often happens here is you look at when data changes significantly. So rather than recording all of the data changes in your historian, you only you only store when it changes, right? So you get a slightly different graph. In this case, the red dots on the graph are when the data has changed. And so if we look at what that looks like as a graph, you can see that it looks somewhat different from the original data set. It's got the general trend, which is often what people wanted. They wanted to know the general trend of the data. They didn't necessarily need to know the complete details. However, this can lose some important information that's very useful when we start to feed it into machine learning techniques and AI solutions. So this can mean that it can become difficult to train well on a historic data set, and you're likely to have sort of worse performing models based on it. So often sort of these techniques need to be changed to allow for sort of the new uses of the data. So this sort of journey is a bit of a cycle where you find particular problems you have in your current set of data, you work on them to change your policies and make that data set better, and then potentially add new measurements as well into the way you're doing things, because you've identified new places you could get useful data in sort of a new way of doing things. And then you sort of continue on that. That part of like getting through that journey of getting better data is one of the big time-consuming parts of sort of this data analysis and data science work in general. So,
yeah, ultimately, it's also going to be something that there's never going to be perfect data, especially in the mining context. You know, I heard people talk about how complicated and messy and difficult mining is as a process, and that is reflected in the data. There is inaccuracy and uncertainty in the model, in the data that we get. But ultimately, any modeling effort and any use of that data really needs to rigorously or robustly reflect that uncertainty and take it into account. Not doing that would be, in a way, it would be kind of misleading. It could give a misleading picture. I'll give a very simplified example of a prediction model that is telling us that a certain key predicted variable is going to be a certain value in a certain amount of time. So this could be, to be a bit more concrete, it could be something like a bearing pressure in a SAG mill 10 minutes ahead of time or an hour ahead of time. And we know that there are certain safety limits. There are certain levels beyond which we don't want this value to go. It would cause an issue, a problem with the piece of equipment if the value went beyond that. So the question is, given a prediction like this, how close do we allow that prediction to get to that safety limit before we start to take action and avoid hitting that safety limit? And the answer is, it's very difficult to know just based on this information. But if we start to incorporate the uncertainties that we know are there in the data, treat them with respect, treat them properly, and incorporate them into our modeling, we can change a single prediction to something that's a bit more reflective of the uncertainty in that process, and reflective of the situation, and gives us a better estimate. Actually, we know this prediction has only a certain amount of reliability or of accuracy, of precision. So let's try and quantify how much precision that is. And then we can change the decision rather than how far do we push this? Now the decision becomes actually how much risk can I take? How will I take 4% chance that I'm going to hit they hit the safety limit, or will they take a 19% chance? Both of those predictions have the same predicted value, but they have different uncertainties, and as a result, the risk to this to the process, the risk to the system is very different. So in particular, our machine learning models, but a lot of the time when we're developing models at IntelliSense.io, we try to use approaches that reflect the uncertainty in the input data, reflect the uncertainty in the processes that we're modeling. We try to use Bayesian approaches as much as possible, and we produce probabilistic predictions. And the result is that we can make more reliable decisions. During the product launch just earlier today, Mark was showing you some of the features of our configurable optimizers, where you can actually set the priorities of your model. Now, all of those priorities reflect the uncertainty in the process that is being modeled behind the scenes. So you set a limit, it's going to treat that limit as it's going to look at the probability of reaching that limit, and so it will use that and how certain we are that whether we're going to breach the limit or not in its recommendations. So the last section I think we're going to move on to then is around interoperability and linking up systems together on the mine site.
Yeah, I'm just trying to go through this a bit quickly, so we've got some time for questions. So interoperability has been touched on a little bit in some of the other sessions, but obviously we've pointed out earlier, like a lot of big data sets are important for being able to make use of machine learning and AI techniques. So what that means is you actually need to bring together potentially a lot of data sets on site. So, and there are a lot of data sets on site, such as sort of the geological models, your fleet management systems, site scans, shift reports, SCADA systems. It's already there, but a lot of the time they're sort of by themselves. And what we need to do is bring them together to be able to then link up the different pieces of equipment. So the data from the stockpile and put that into the crusher model so you can see what's coming. So some of those systems already have sort of quite good standards. So things like SCADA systems, the OPC standard is quite robust, and the latest one has even added sort of more security, so such that you could use it safely over an internet link. And other systems maybe are a bit earlier on that journey, and so the standards are starting, but there's probably a little bit more to go. So this kind of area of getting this data together is a big piece to be able to then make use of your data for important, like for the future stuff. But even with systems that do have data, you can have problems using them in a different way. So using them on machine learning, where it reads a full data set for all the variables that you're putting into it, could cause problems on your SCADA systems when you sort of read out that load of data. And no one wants to cause issues with production systems, especially the ones that are controlling the mine itself. So yeah, there's a few things to be aware of with that. So often the option has been like you do extracts from systems, and you have there's problems with that as well, where you can have extracts which sort of different versions end up everywhere. You're not sure which one you're using. You might end up training data on an old extract, meaning it doesn't perform as well. So there's some potential problems with that too. So what we're sort of suggesting people do, and what we're seeing is a trend towards data lakes. So keeping all of your data in the one location, bringing it all together in a semi-structured format. And this sort of lets you then build on top of that. And this then saves a lot of time for anyone else bringing in sort of other techniques and technologies, because there's already one place where you can integrate it with to sort of gather all that data. It's already been brought into the one place, ready for sort of future work. So this is kind of the thing we see, where the data lake is going to become sort of an important key point for both sort of AI and machine learning on site, but potentially a lot of other innovative techniques that we haven't even seen yet because it doesn't exist yet. And so we are seeing an industry trend towards data lakes, and obviously cloud infrastructure makes them sort of a bit easier to build up.
Just to finish, the takeaway from this really is to think about the ways in which you can look at taking advantage of the AI future, the machine learning and big data progress that is taking place. Develop a strategy. Think about what would be required to make it part of your operations. Look at bringing data together from different siloed sources, building a data lake, and accept the fact that improving the data quality is going to be a journey, and start down that path. Because at the end of the day, that good data that you develop in a single place, potentially with cloud resources behind it, is going to become a strong advantage. It's going to make a big difference. And ultimately, the advantage that makes is around making things more efficient, making things more running in a more optimized fashion. And that's not just good for operations, it's not just good for the people running it, it's good for the planet, and it's good for the world.
Yeah, exactly.
So thank you very much, everyone. And I am going to move on, and we're going to move on to a few questions.
As many as we can get through.
As many as we can get through. So we have about 3.5 minutes. So the first question, it's going to be a fun one. So advanced models always start good, but quickly become useless. Can you avoid that?
I think I'll let you answer that one.
Oh, okay. Well, one of the ways we avoid that, as I mentioned here, is to take account of the uncertainty. So at the very least, when a model starts to become less certain of what it's predicting, we know it. We can see that showing up in the predictions that it's making. And the other big way that we can do it is through regular retraining, so recalibration. When all of the data is being stored in one place, and when you have the resources of a cloud to spin up on-demand computing resources and computing power, you can just run a retraining on a regular basis that will make sure that your model takes account of the latest happenings, the latest data that you've received.
Yeah, good point. I mean, we're seeing sort of a retraining schedule of about every 3 months at the moment, but it'll depend on some of the other processes we're putting in place as well.
So. I have another one here. How are IntelliSense.io able to deploy and work with the different types and combinations of infrastructure, public, private, and on-site?
Right. I mean, so because we sort of saw this coming with having to both make use of the cloud and the cloud tools out there, as well as have to deploy sort of on-premises work, we went with sort of a cloud agnostic strategy, or a deployment agnostic strategy. So for a lot of our technology, we deploy it with Docker and Kubernetes, which are tools around managing, running and deploying software easily in any computing system. And so we've made big use of that to sort of enable us to work on any public cloud or any sort of on-premise infrastructure.
That's great. Good question. I think we have time for one more question here. So what are the main challenges for scaling up mining specific software as a service solutions?
I think well, there's a few there, but I think that sort of data integration piece is always been a big thing. There's a lot of different software out there, and a lot of different potential sources of data, and the data integration itself can take a lot of time to integrate that. And there may be differences in the different software, different problems that might come out of it because of the different way it stores that data. So the trend towards data lakes we're seeing is a good thing because it simplifies that integration piece. And so that'll be an exciting thing for the future, and it will speed up the deployment and enable this sort of technology in the future.
Excellent. I think that's about all we have time for. So thank you all very much for the questions. There's a number of other questions that we'll try and respond to after offline.
Mm-hmm.
Now we're going to move on to the closing session of the day, and it's going to be Sam and Shona are going to take over from here. Thank you, everybody.
Thank you all.